Chapter 9.3 triangles. Okay, first of all, here is a right triangle. Okay, right triangle means one angle is 90 degrees. Okay, then these two sides on this 90 degrees called the leg. So there are two legs, let's say AB, and the longest side is hypotenuse. We call this hypotenuse. Okay, so there are three sides. This is the right triangle. Okay, right triangle, and this side is A, and this side is B, and this hypotenuse is C. Okay, look at this. Each corner is ABC, and the opposite side to the corner, the vertex has the same alphabet. So we have on the top part, the vertex on the top is A, capital A. Then the opposite side is lowercase a. Okay, so the vertex is always usually used the uppercase, and then the side length is using the lowercase. Okay, usually. So in this case, here's a very important. For the right triangle, we call here is a Pythagorean theorem. Okay, this means the square of the hypotenuse. So c squared is equal to the sum of squares of two legs, A and B. So this is the formula. Very, very important formula. So in the right triangle, always c squared is equal to a squared plus b squared. Okay, don't forget this. Then c is equal to what? Then from this, we can write it something like this. We want to find c, not c squared. So c is equal to, take the square root on the right hand side. So a squared plus b squared. All right. So if we want to find c, then c will be square root of a squared plus b squared. Okay, how about, can we find a? How do we find a? Let's say we want to find a. Then from using the Pythagorean theorem, c squared is equal to a squared plus b squared, right? So if since we want to find a squared, so move this b squared to the left. Okay, minus b squared each side. Then what we have is c squared minus b squared. So that is equal to a squared, right? Then a is equal to, so we want to find a, not a squared. Then what do we do on the other side? Take the square root. So b squared minus, so c squared minus b squared. So if you want to find a, then the answer will be square root of c squared minus b squared. So the hypotenuse squared minus square of the other leg. Okay, and then you want to find c, then what? Hypotenuse c, then there will be square root of a squared plus b squared. All right, and this is a proof. So for the proof, okay, let me explain this formula, how we got this formula. Okay, so draw the right triangle like this. Draw a right triangle. So let's say B is the shorter side, A is the longer side. And this is 90 degrees. Okay, then this is the longer side. And then rotate this angle, this triangle on the right side, and then put it. So I'm going to rotate it. So the shorter side goes here, and the longer side goes here. And this is the hypotenuse C, right? So each side will have AB, right? AB. So that on the right side, we will have A. So the shorter side comes here, the longer side comes here, So the triangle is located here. Can you see it? So right side is AB, and then the top side is also AB. So you have longer side, so shorter side goes there, and this is longer side, and this is C. So each side, the length of each side is A plus B, right? A plus B, and the center is C squared. All right, so as you see this one, this is square, right? Square. We have a square. We just draw a square, large square, and then the inside is small square. So the large square is equal to what? Large square is A plus B, right? A plus B. Each side is A plus B. So the area of the largest square is A plus B squared, right? Because A plus B is multiplied twice. And then there are how many figures inside this square? So here it is 1, 2, 3, 4. 4 identical triangles, right? So the area of a triangle is A times B divided by 2. And there are 4 of them. So this is the area of 4 triangles, right? And then we have inside there is a square. Each side is C. Each side is C, right? C. So the area of this little triangle inside little square is what? C squared, right? C squared. So we have an equation like this, and then solve this equation, not solve, simplify the equation. Then you will get A squared plus B squared equals C squared. Okay, so proof is really simple. So there are many different ways of solving the Pythagorean theorem, but this is one of them. Really simple proof and easy to understand. All right, then let's try some examples. Okay, here's a right triangle, and the length of each leg is 12 and 9. Then what is the length of the hypotenuse? So use the formula. C squared equals 9 squared plus 12 squared. So C squared is 225. This is square, right? So we want the base C. So C will be equal to what? Put square root on the right hand side, 225. So 225 is 15 squared, so C equals 15. Okay, how about this example? Okay, 2 legs are 5 and 12. So C squared is 5 squared plus 12 squared. Okay, then this is 169. So the length C will be take the square root on the right hand side. Square root of 169, which is 13. So we do the same thing on this case. Okay, how about this one? Here's B. Okay, B is not hypotenuse. B is the leg, right leg. Okay, so use the formula. The hypotenuse is 12. So 12 squared is equal to B squared plus 8 squared. We want to find B squared, right? B squared. So move A squared to the other side. Or subtract A squared from each side. So B squared is 80. Then B equals what? Square root of 80. So using a calculator, it is 8.94 is the length of side B. All right, how about this one? Same thing. We are looking for the length of side leg, right leg, A. So use the formula, plug in the values 2 and 6, and A is the leg. So what we do is C squared minus B squared, right? Okay, so A squared is equal to 6 squared minus 2 squared. Okay, now here is similar triangles. This is also an important concept. Similar triangles means two triangles similar, which means you have one triangle, and this triangle is enlarged or shrinked. Enlarge or make it small, make it bigger or small. So these triangles have the same corresponding angles, like this. let's say there are three different angles, right? Three angles. So you enlarge it. So let's say this is 1, 2, 3. Then this one is 10 times. These two became 20, and this is 30, right? What we did is we enlarged 10 times each side. And this angle and this angle are also the same. And this angle and this angle are the same. And this one is same as this one. So if two triangles have the same angles like this, then these are what? Similar triangles. Similar triangles. Okay. So if you have similar triangles, then the ratios are the same ratio. As you see this one, 1 is multiplied by 10 to get this side. Then this side also must multiply by 10 so that you have this length. And the third length should be multiplied by 10, so you got this length. Okay. So that is the power of similar triangles. So the ratio of corresponding sides are equal always. If two triangles are similar, then the ratio of the corresponding sides are equal always. Okay, the ratio of corresponding height is equal to the ratio of corresponding sides. Same thing, same meaning. So look at this one. Let's say these two are similar. Okay, are these similar? Okay, let's check if the corresponding side, the ratio of the corresponding sides are the same. Okay, this is 2. The length of this one is 2, and this one is 6. So 6 is 2 times 3, right? 2 times 3. So 2 multiplied by 3 is 6. How about this 3? So let's multiply this 3 by 3. 3 times 3 is 9, right? Okay, good. And this 4 times 3 is what? 12. Yes, so the ratio are the same, right? So each corresponding side has the same ratio. So these two are similar, right? How about this? Okay, in this case, these two triangles are similar. Are they really similar? Okay, let's check. Okay, the height is 1 by 1. Then 1 became 4 by multiplying by 4, right? 4. So 1 times 4 is 4. How about this side AB, 1.5. Multiply 1.5 by 4, then that is 6, right? 6. Okay, so these two are similar triangles. Okay, here's a question. Okay, let's say these two triangles are similar. Okay, then what is the length of EF? What is the length of this side? Okay, so let's use a proportion. So 6 to 10. Okay, these two are the similar. These two are the corresponding side, right? So 6 to 10. So side AB to DE. Here AB to DE, right? AB to DE should be equal to what? Length CB, right? CB for CB to or BC, CB or BC to EF, right? EF. Make sense? Okay, so this length to this length should be equal to this length to this length. So AB is the first triangle. DE is from the second triangle. So this one should be equal to the length from the first triangle to the length of the second triangle. Okay, then I solve for, and then replace these variables to the length. So 6 to 10 equals 4 to EF. Then cross multiply, right? Cross multiply. So 6 times EF equals 4 times 10, which is 40. Then divide by 6. Okay, and next, okay, corresponding angles are, I just explained, right? Corresponding angles is it has to have the same location. Okay, so here's a triangle. So, look at the triangle and then look at the side length. The side lengths are all different, right? One is small, medium, and large. So small, medium, large, and they are the corresponding side. Okay, let's say these two are similar. Is this similar or this is a different? Okay, so this is similar triangle. Okay, so let's check. So let's write an equation. Okay, AB 8 to 12. Then that should be equal to what? So AB, the numerator comes from the first triangle. Okay, and then this one should be equal to, this one shows the height, right? Height. So this height 4 to this height x, right? So we are looking for FG, right? FG. What is this guy? What is this length? What is this height? So solve for x. So that is 8x is equal to 4 times 12, right? And divide, so 8x is equal to 48. And divide each side by 8. Divide each side by 8. So x is equal to 6. Make sense? Okay, the next example. Okay, these two are similar. So we can write an equation using ratio proportion. Okay, side length 10. So 10 over 15. So that is equal to 7, the height 7 over this height. Let's say that is x. Then you can find x. So cross multiply, so 10x is equal to 7 times 15. Right, then 10x is equal to 105. Then divide each side by 10, so x is equal to 105 over 10. So 10.5. Okay, so similar triangle is really useful definition. So using the similar triangle property, you can find sides of unknown side length. Okay, now congruent triangle. Okay, congruent triangle is different from similar triangle. Similar triangle has different side length. I mean the corresponding side lengths are the same, are different. So similar triangles, one triangle is small and the other triangle is always large. That is similar triangle. But congruent triangle means exactly the same. Two triangles are exactly the same shape, same size, same side length, always. That's congruent triangles. So there are three properties, which means side. We use SSS. So the corresponding sides are three corresponding sides are the same. Side one are the same. Okay, in this case, this side and this side are the same, right? And then this side and this side are the same. And the third side, this is 4 and this is 4. Same, right? So these two triangles are congruent. We call it congruent, which means all three side length, corresponding side lengths are the same. Okay, side. Or side side angle side, SAS. This means you have one side and one angle, and another side are the same. So let's try this. You have a side length 7, right? Your side length 7, and the next is 120 angle, 120, right? And the next is 4, side length 4. So if we have this condition satisfied, then two triangles are congruent. So starting from one side, angle and side are the same, then they are congruent. Okay, how about the next one? ASA, angle, side, angle. So let's start from angle. So angle 15, side, and angle 40. So do we have same information on the other triangle? Let's check. 55, 9, 40. So here it is. It's a 55. Yeah, 55. This is 55 angle, and this is side length 9 and angle 40. So these two are congruent. So for the congruent, we use the symbol equal sign and then a wave sign. This is congruent. So these two triangles are congruent, and these two triangles are congruent. So congruent means twins. Twins. They are exactly the same. So exactly the same, which means side lengths are the same. Corresponding sides are exactly the same, and then corresponding angles are exactly the same. That is congruent. So there are three properties: SSS, SAS, ASA. Okay. How about angle? Does this property makes congruent triangle? No. As you see these two triangles, these are similar, right? Similar. Three angles are the same. Three corresponding angles are the same, but this is not congruent. One is small, one is larger. So for this one, this is similar, right? Similar. AAA indicates two triangles are similar triangles. Okay, similar triangles, not congruent triangles. So only these three makes congruent triangles. Congruent. SSS, SAS, ASA. Okay, so ABC and DF, are they congruent? Okay, let's check. Look at this. This is 45, 45, 55, 55, and the angle is 80. So corresponding angles are the same. So this is similar, not congruent. Right? It's not congruent, it's similar. Angles, corresponding angles are the same. AAA, that is similar triangle. So this one does not satisfy SSS, AAA, SAS, SAS, ASA, right? These properties are not satisfied, so this is not congruent. How about this one? 16, you have 16 angle, so side angle side. 16, 60, 80, 18. So you have 16, 60, 18. The corresponding angle side angle side are the same. Side 16, angle 60, side. So side angle side rule is satisfied. So these two triangles are congruent. Make sense? All right. I think that's it for this section. Okay, so for this one, we gotta understand the formula for this Pythagorean theorem. Okay, Pythagorean theorem. So when you have a right triangle, always hypotenuse squared is equal to the sum of the squares of two legs. Okay, c squared is equal to a squared plus b squared. So if we want to find c, then get rid of the square root. So get rid of the square root so that the right side will be square root of the right hand side. Okay, square root of the right hand side. Okay, and the similar triangles. Two triangles are similar if the corresponding angles are the same. So one is small, one is larger. Okay, enlarge the triangle or shrink the triangle. Then they are similar triangles. So for the similar triangles, the ratio of the corresponding sides are equal. The ratio of corresponding sides are equal. That's really important. And congruent triangles means what? Two triangles are exactly the same. So the corresponding sides are the same, and the corresponding angles are the same. So we can use SSS rule, SAS rule, or ASA rule. ASA rule. Okay, that's it.